Hello everybody. Well, we are here to discuss the very CBSE pattern question exercises for linear inequations. Let's begin with the first question. It says, solve for x this particular linear inequation. 4x plus 3 is less than 6x plus 7. So if we have 4x plus 3 is less than 6x plus 7, the three rules which are required basically to solve any linear inequation is what? What are the rules? The first rule was, you can add anything to both sides of the inequation, you can subtract anything from both sides of the inequation, the sign of the inequation does not alter. Second rule, you can multiply or divide by any positive quantity on both sides of the inequation, the sign does not change. But if you multiply or divide by a negative quantity, the sign of the inequality reverses itself. Less than becomes greater than becomes less than equal to becomes greater than equal to becomes less than equal to. And third one was, you can take one term from one side of the inequality to the other side by changing its sign without changing the sign of the inequality. Keeping these three rules in mind, let's begin tackling all the questions. In here, I am interested in doing what? Well, 4x, I will bring everything related to the variables on one side, everything related to the constants on the other side just by using the rules. I am removing, or basically I should say subtracting 6x from both sides, that means 4x minus 6x, and I am also subtracting 3 from both sides. That is not going to change my inequality. 3 will be subtracted from here, so I will be left with 0. 6x is subtracted from here, so I am left with 4x minus 6x. 6x is subtracted from here, so this is 0. 3 is subtracted from here, so this is what you are left with. So 4x minus 6x gives you minus 2x is less than 4. Or 2x is greater than minus 4, isn't it? Because I am basically multiplying by minus 1 on both sides, that eventually led to the reversal of the inequality sign. Now I am basically going to divide both sides by 2. That means I am dividing by a positive quantity. When 2x is divided by 2, you get x. Because positive quantity I am dividing by, therefore inequality does not change. Minus 4 divided by 2 gives you minus 2. And therefore your answer is x belongs to minus 2 comma infinity. Solution set is this. Fine. If you wish to plot it on the number line, you can do that. This is minus infinity, infinity. This is say minus 2. From minus 2 to infinity, minus 2 opens, so there is actually a hollow circle over here because I am not including minus 2. And from minus 2 to infinity, so you just bold this part up. That means everything minus 2 onwards excluding minus 2. Clear? Moving on to the next question we have. Solve 30x is less than 200 for x being a natural number and then for x being an integer. That's pretty nice. 30x is less than 200. Dividing both sides by 30 because I want x alone, then only I can get the solution. If I am dividing both sides by 30, 30 is a positive number, therefore inequality sign is not going to alter. When I divide both sides by 30, 30x by 30 gives me x. Inequality remains the same. Here I have 200 by 30. 6.6. So x is less than 6.6. First part. I want all the natural numbers which are solution of this inequality. All the numbers which are solution of this inequality are those numbers which are strictly less than 6.6. If I want solution in natural numbers, that means I want those natural numbers which are strictly less than 6.6. Natural numbers begin from 1, then it is 2, then 3, then 4, then 5, then 6, then 7 and 8. Which are the natural numbers strictly less than 6.6? The natural numbers which are solution of 1 are what? Which are the natural numbers strictly less than 6.6? 1, 2, 3, 4, 5 and 6. Therefore, solution set in this case is this set. It is these natural numbers which are solution of this particular inequality. Now I want solution in the set of all integers. Which are all the integers strictly less than 6.6? Well, if I talk about integers, integers are what? dot 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 -3, -2, -1, 0, 1, 2, 3, 4, 5, 6 and so on, right. I need to be taking up numbers strictly less than 6.6. That means all the integers strictly less than 6.6 will be what? Solution set in the set of all integers is all these I can take. All these integers are less than 6.6. This is also less than 6.6. And that is it. The next integer would be 7, which would not be less than 6.6, and therefore it won't be a solution of this inequality. These are all the integers, infinitely many, which are solution of this inequality. So in the set of natural numbers you have only finitely many solutions, but in the set of integers you have infinitely many solutions. All these infinitely many integers, -5, -6, -7, -8, -9 and so on, they are all strictly less than 6.6 and hence qualify to be the solution of this particular inequation. Next we have solve this particular inequality. Well, these are actually two inequations given. So it is nothing but a system of inequations actually given to you. So let's write it separately. We have what all we have. One is going to come from here, another is going to come from here. One is -5 is less than equal to 5 minus 3x upon 2. Another is 5 minus 3x upon 2 is less than equal to 8. Solving the system means solve this, find out their individual solution sets. Next step, take the intersection of their solution sets. Whatever that intersection set comes out happens to be the solution of the system. That's the drill. Talking about solving one. What can you say over here? In order to solve this, what do you need? You need to get rid of this denominator. So I will be writing multiplying both sides by 2. 2 is positive. That means inequality won't change. When you multiply both sides by 2, you get, so you can just start this by 5 minus 3x by 2 is greater than equal to -5. Multiply both sides by 2. If this is multiplied by 2, 2 cancels out. You have 5 minus 3x is greater than equal to -10. Now you can add 10 both sides and add 3x both sides. Inequality won't change. When you add 10 here and you add 3x here, minus 3x plus 3x is 0. When you add 10 here, minus 10 plus 10 0, and you add 3x here. So you have 15 is greater than equal to 3x. And the next step, in order to leave x alone, I will be dividing both sides by 3. 3 is positive, inequality won't change. 15 divided by 3 gives me 5. 3x divided by 3 gives me x. And therefore, solution set of first inequality is x less than equal to 5. That means minus infinity 5, 5 closed. Fine. That means if this is 5, I am including 5 and everything before 5 up till 5 is the solution on the number line. Talking about the second one, 5 minus 3x upon 2 is less than equal to 8. Multiplying both sides by 2, 2 is positive, inequality won't change. 2 multiplied, 2 cancels out. 5 minus 3x is less than equal to, this is 16, 8 into 2 is 16. Now I am adding 3x both sides and subtracting 16 from both sides. Adding 3x both sides, subtracting 16 from both sides gives me this. And from here you have minus 11 is less than equal to 3x. When you divide both sides by 3, 3 is positive, inequality doesn't change. Minus 11 by 3 is less than equal to x, or x is greater than equal to minus 11 by 3. And therefore, solution set of 2 is x is greater than equal to minus 11 by 3. So, minus 11 by 3 comma infinity, which on the number line if you plot, this is say minus 11 by 3, I am including minus 11 by 3 and everything beyond it is my solution. I have found the solution set of 1, I have found the solution set of 2, I need to find the solution set of the system. Does solution set of the system, solution set of the given system is equal to minus infinity comma 5 intersection this solution set. Fine. How do you actually understand this? In one particular real line only, we are going to plot both the solution sets. Here you have minus 11 by 3 and somewhere here you have say 5. So one says minus infinity to 5, 5 included. 5 is included. So you basically have this complete thing, 5 is included. Okay. Next you have minus 11 by 3 comma infinity. This is also included. And you have from here till here, this complete solid portion. What is the common region? Clearly this is the common region, right? And the intersection comes out to be minus 11 by 3 comma 5. Is it clear? That happens to be the solution set of your given system. After this we have solve this inequation 3x plus 17 is less than or equal to twice of 1 minus x. This is just one single inequality, not a system. So we have 3x plus 17 is less than or equal to 2 minus 2x I can write. Simplify as much as you can. Adding 2x both sides. Adding 2x both sides gives me this, and subtracting 17 from both sides gives me this. So you have 5x less than or equal to minus 15, x is less than or equal to minus 3. Why? Because I have divided both sides by 5, 5 is positive, inequality remains the same. This implies x belongs to minus infinity to minus 3 closed. X is less than or equal to minus 3, that means x belongs to minus infinity comma minus 3 closed. Therefore, solution set is this only. And on the number line, if you wish to plot it, you can do that. Say this is minus 3, then from minus infinity to minus 3 included is the representation of the solution set on the real line. Next question says that in an experiment, what is happening is, let's try and understand this question. In an experiment, a solution of hydrochloric acid is to be kept between 30 and 35 degrees Celsius. What is the range of temperature in degree Fahrenheit if this conversion formula from Celsius to Fahrenheit is given to you? Fine. So in Celsius, the temperature is lying between 30 and 35. In Celsius. So in Celsius, the temperature is lying between 30 and 35. But Celsius is given to me as 5 by 9. C can be replaced by 5 by 9 into F minus 32. So that means this is lying between 30 and 35. C is equal to this only. Now you can consider this as 1 and consider this as 2. If I talk about 1, I have 30 is less than 5 by 9 F minus 32. 9 is multiplied both sides. I have divided by 5 both sides. So now you are left with this. Inequality doesn't change at all are positive. 54 plus 32 is less than F because I have added 32 both sides. One thing has given you this, one particular part of the inequality has given you this about Fahrenheit. And let's talk about the second. I have 5 by 9 F minus 32 is less than 35. Again, multiplying both sides by 9, dividing both sides by 5 has given me F minus 32 is less than 35 into 9 divided by 5. That is F is less than 63 plus 32. Why? Because I have added 32 both sides. 32 is any number you can add both sides. Inequality doesn't alter. F is less than 95. So therefore, range in your Fahrenheit is that it should be less than 95 and it should be greater than 86. Is it clear? That's how one of the applications also come of linear inequations. Next we have solve the given system of inequalities and represent the solution on the number line. Here also system is given to you, so you will be individually first solving both the inequalities, obtaining the solution sets, taking the intersection, obtain the solution set of the system, then plot it on the real line. So one I have 3x minus 7 is less than 5 plus x. Subtract x from both sides and add 7 both sides. Cool? 2x is less than 12. Now divide by 2 from both sides. Divide both sides by 2, you get x is less than 6. Therefore, solution set of this first linear inequation is x is strictly less than 6. That means this is the solution set. If you plot it, what do you see? If this is 6, I cannot include 6. So hollow circle at 6 and everything before 6. That's the representation on the real line. And now if I talk about the second one, it is 11 minus 5x is less than or equal to 1. 11 minus 5x is less than or equal to 1. Clearly adding 5x both sides, subtracting 1 from both sides. 10 is less than or equal to 5x. Dividing from 5 both sides, you get 2 is less than or equal to x, or x is greater than or equal to 2. Fine. If x is greater than or equal to 2, therefore solution set of 2 is this. You can represent it on the number line. This is 2. 2 will be included this time. It's closed interval and everything after 2. Clear? I need to find out the intersection of both these solution sets. So I am saying solution set of the system is minus infinity comma 6 intersection 2 comma infinity. If I draw this intersection on the number line, basically this is 2, say this is 6. One is including 2 and everything after it, and other is excluding 6 and everything before it. So common portion comes out to be this one, this complete and hollow 6. So the intersection is actually 2 comma 6, 2 closed, 6 open. Clear? Moving to the next, we have solve the following inequation. Now this is given in the form of a rational function, so special treatment needs to be done to it. I cannot just straight away take x minus 1 this side, or I cannot say multiplying x minus 1 both sides so that I can get rid of this x minus 1 denominator by cancelling it out, because I don't know whether it is positive or negative. Depending upon x minus 1 can be positive or negative, and therefore I don't know how this particular sign will be changed or will be treated. That is why I cannot just say that multiplying both sides by x minus 1 and hence cancelling out x minus 1 by retaining this inequality sign. It may get changed depending upon x minus 1 being positive or negative. So how do you treat such inequalities? You have 2x plus 4 upon x minus 1. You bring 5 this side. You actually subtract both sides by 5. So you get this. Subtract both sides by 5, you get this. This gives you 2x plus 4 minus 5 times x minus 1 whole upon x minus 1. I am just going to do everything on the left hand side. I am trying to simplify it as much as I can. 2x plus 4 minus 5x plus 5 whole upon x minus 1 is greater than equal to 0. 2x minus 5x is minus 3x plus 9 upon x minus 1 is greater than equal to 0. Or I can just take out minus common, 3x minus 9 upon x minus 1 is greater than equal to 0. If I multiply both sides by minus 1, I get 3x minus 9, which is 3 times x minus 3 upon x minus 1 is less than equal to 0. Because when you multiply both sides by minus 1, actually your inequality changes from greater than equal to less than equal to. Now you have 3 is multiplied by x minus 3 upon x minus 1 and the answer is negative. 3 is positive. If it is being multiplied by this and the answer is coming out to be negative, that means this quantity has to be negative. For 3 into something to be negative, this quantity has to be negative. For 3 into something to be 0, this quantity has to be 0 because 3 is non-zero. That means for 3 into something to be less than equal to 0, x minus 3 upon x minus 1 should be less than equal to 0. After this, for which values of x is x minus 3 upon x minus 1 less than equal to 0? X minus 1 equals 0, give me 1, x minus 3 equals 0, give me 3. If I put x equals 1, numerator will be minus 2, denominator will be 0, this quantity will not be a real number and therefore I cannot take x equals 1. X equals 1 is not a solution. It is not giving me a real number as the answer over here. If I take x equals 3, I get 0 upon 2, which is 0, and I want x for which this expression is 0, so 3 is definitely going to be taken. Now if I talk about values which are lying before 1, between 1 and 3 and beyond 3. If I take any number before 1, suppose I take 0, you get negative here, negative here, negative, negative gives me positive. So you get positive answer here. Here if you put any value beyond 1 and less than 3, suppose 2 you put, you get negative above, positive below, so you get negative answer and here you again get positive answer. You want all those x for which the answer of this expression is either less than 0 or equal to 0. From greater than 1 and less than 3 you are getting negative answer, at 3 you are getting answer equal to 0, at 1 it is not defined and therefore solution set is 1, 3. Clear? That is what is your solution set of this given inequality. Next question we have, solve the following system of inequations. It's given to us, this system is given to us. Let us try and solve this out. Again it's a system, this is 1, this is 2, twice of 2x plus 3 minus 10 is strictly less than 6 times x minus 2. Sort this out, 4x plus 6 minus 10 is less than 6x minus 12. 4x minus 4 is less than 6x minus 12. I can just bring x's together. This gives you minus 2x is less than minus 8 or 2x is greater than 8. This gives me x is greater than 4. So one solution set is, solution set of 1 is 4, infinity. Then if I talk about the next one, I have 2x minus 3 upon 4 plus 6 is greater than equal to 2 plus 4x upon 3. Just sort it out, you get 2x minus 3 plus 24 whole upon 4 greater than equal to 6 plus 4x whole upon 3. Multiply both sides by 3, then multiply both sides by 4. Basically what are you going to get? 3 will be multiplied here, 4 will be multiplied here, both are positive, inequality doesn't alter. So 3 into 2 you get 6x minus 9 plus 72 greater than equal to 24 plus 16x. This gives me what? This is 63, right? Greater than equal to 24 plus 16x. After this basically you need to bring all the x's one side, all the constants on the other side. 6x minus 16x is greater than equal to 24 minus 63. This gives you minus 10x. is greater than equal to what is 63 minus 24? This gives you 39. 24 minus 63 is minus 39, or you can just multiply both sides by minus 1, you get 10x less than equal to 39, or x is less than equal to 39 by 10, that is 3.9. And therefore, solution set of this given inequation is 3.9 comma infinity. If I have the solution set of both the given inequalities and I want the solution set of the system, I am only supposed to take the intersection of both the solution sets. Solution set of the system is 4, or I should write 4 comma infinity. This is x is less than equal to 3.9. Less than equal to 3.9 means what? Minus infinity to 3.9. One is 4 comma infinity, other is minus infinity to 3.9. Just try and see what the intersection comes out to be. Say this is 3.9 and after it is 4. One is 4 comma infinity, 4 not included, so 4 comma infinity is this. Then you have 3.9 included and everything before it. Can you find out any intersection between these two regions? One is 3.9 and before 3.9, one is not 4 but everything beyond 4. Clearly the intersection is an empty set, and therefore system has no solution, because absolutely no intersection is there between the solution sets of both the inequalities which are forming the system. That means there is no x which is satisfying inequality 1 also and inequality 2 also, and therefore there is no particular x which is a solution of this system. Moving to the next, we have a manufacturer has 600 liters of a 12% solution of acid. How many liters of a 30% acid solution must be added to it so that the acid content in the resulting mixture will be more than 15% but less than 18%. So let me say that let x liters of 30% acid solution be added. Question is saying how many liters of a 30% acid solution must be added so as to get the acid content of the resulting mixture be more than 15% and less than 18%. Now what will be the resulting mixture? 600 liters was already there. I have added x more liters. Therefore total mixture is 600 plus x liters. This is the resulting mixture. Now it is saying 30% of x plus 12% of 600. This should be more than 15% of the resulting mixture, and 30% of x plus 12% of 600 should be less than 18% of resulting mixture. So this is going to give rise to two inequalities before us. Let's just try to sort them and get the range of x. Okay, so this is basically acting as one inequality, this is acting as the second inequality. 30% of x means 30x upon 100 plus 12% of 600, so it is 12 upon 100 into 600. This is greater than 15% of 600 plus x, and then you have 30x upon 100 plus 12 upon 100 of 600 is less than 18% of 600 plus x. Sort it out. 30x plus 7200 whole upon 100 is greater than 9000 plus 15x whole upon 100. And again 30x plus 7200 whole upon 100 is less than 10,800 plus 18x whole upon 100. If you multiply by 100 both sides in both the inequations, you get 30x plus 7,200 is greater than 9,000 plus 15x, and 30x plus 7,200 is less than 10,800 plus 18x. You need to sort this a bit more. So let's sort it out. 30x minus 15x is 15x is greater than 9,000 minus 7,200, which is 1,800. So you have 15x is greater than 1,800, which implies x is greater than 120. And again you have 30x minus 18x, that is 12x, is less than 10,800 minus 7,200, that is 3,600, which implies x is less than 300. Therefore, x is greater than 120, less than 300. So, x liters that we had chosen has to be greater than 120 liters and less than 300 liters. That is the range for which these many x liters of 30% acid solution must be added so that the acid content in the resulting mixture will be more than 15% and less than 18%. This can happen only when x liters are actually greater than 120 liters and less than 300 liters. We have got the range. Next we have exhibit graphically the solution set of the linear inequations which are given to you in here. So one by one, let's begin drawing, plotting, and then we are going to find the intersection graphically of the solution sets and then declaring the solution of this complete system. Now in here, first one is x plus y less than equal to 5. What is the drill? If I have x plus y less than equal to 5, x plus y less than equal to 5, I would first be considering x plus y equal to 5. Draw it. When x is 0, y is 5, and y is 0, x is 5. So basically you have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Join both of them. You have got your line. Now you can see 0, 0 is not lying on the line. If you put 0 over here, 0 over here, 0 is strictly less than 5, and therefore everything on this line and below this line will be the shaded portion, giving you the solution set of this given inequality. Next I have, so below this line, everything below this line, 4x plus y greater than equal to 4. 4x plus y greater than equal to 4. Consider 4x plus y equal to 4. When x is 0, y is 4. When x is 0, y is 4. This is 4. When y is 0, x is 1. So clearly you will have to join these two. This is what x plus y equals 5. This is what 4x plus y equals 4. Now again 0, 0 is not lying on the line. When you put 0 here, 0 here, 0 is greater than 4. No, 0 is less than 4. So everything below here but everything above this line is the solution. Everything above this line, region which is not involving 0, 0 because 0, 0 is not satisfying the inequality, 4x plus y greater than equal to 4. So region which is not involving 0, 0 is the solution. So everything below this line, everything above this line, intersection till now is coming the region between these two lines. Let's talk about some more inequations. We have x plus 5y greater than equal to 5. X plus 5y greater than equal to 5. You consider x plus 5y equal to 5. When x is 0, y is 1. When x is 0, y is 1. And when y is 0, x is 5. When x is 0, y is 1. When x is 0, y is 1. And when y is 0, x is 5. right? When x was 0, y was 1, and when y is 0, then x is equal to 5. This is your x plus 5y equals 5. Again 0 comma 0 is not lying. When you put 0 here, you actually get 0 is greater than or equal to 5, which is false. So everything above this line is the solution region, which is not involving the origin. Next I have x is less than or equal to 4. What is x equal to 4? This is x equal to 4. X less than or equal to 4. Less than means over here. So everything this side to this line. And next I have y is less than or equal to 3. 1, 2, 3. If I talk about y, this is y equals 3. This is x equals 4. And this is y equals 3. Less than or equal to 3 means everything below this line. When you take the intersection of all the regions that you obtain, you actually get this. This bounded region with these boundaries included happen to be your very solution. Fine. The shaded region represents the solution of the given system. You can even write this is A, B, C, D, E. So this you can write. Fine. This is how you need to tackle the questions on linear inequations. That's it from my side. Thank you.